Right. Question 5, we're asked to plot the function 5x cubed minus 8x plus 12 between x equals minus 2 and x equals plus 2. We're also asked to plot another curve on the same graph using the transformed x and y values. So basically we transform that original graph by scaling it by half in the x direction and translating by plus 1 in the y direction. So the first thing we need to do here is actually create the data values. So we go into Excel and we have two columns. The first is for the x range, just label it as such, and the second is the y, and just double checking, it's y equals 5x cubed minus 8x plus 12. Okay, so they're just the labels. Okay, I haven't put any formulas in yet. And just double check that the x range is between minus 2 and plus 2. So we just go from minus 2 to plus 2. Okay, so that's our x column. Now for the y values, we literally put in the formula as we're given. So here we're asked to multiply the x value by 5, but we also need to cube that x value. So it's 5 multiplied by, let's find the multiplication sign. Now instead of multiply by x, what we're doing is we're substituting in the minus 2 instead of the x. So it's 5 multiplied by minus 2 all cubed. Now to cube or square or to raise anything to a value to any power, you use the little hat function over the 6 on our keyboard, and in this case it's cubed. So it's 5 multiplied by, use a star for multiplication, and instead of x, I just click on the first value in the x range there, which is minus 2, and that's cubed. Then that's minus 8 multiplied by 8 multiplied by, again we click on the minus 2, so everywhere there's an x we click on the minus 2, and then plus 12. Now 12 is just a constant, so we just leave 12 always remains the same, doesn't depend on x, so we just leave it at 12, and we just press enter, and that should give us the y value, the corresponding y value for the x value minus 2. So this gives us our first two x and y coordinate values, minus 2, minus 12. So basically what we want to do is do the same for the other four values. So instead of, for the second one, instead of minus 2, we're subbing in minus 1. So it becomes 5 times minus 1 cubed minus 8 times minus 1 plus 12, and so on. But we can use autofill for this, so we can just drag down with the right mouse button and fill without formatting, and that should give us the corresponding values. So now we have 5 points to plot on our graph, and that should give us enough to show us to give us a good idea of the shape of the graph. So what we do here is we select the values. Again, we go to insert, but in this case we select scatter. Okay, not line, which looks most obvious, but it's actually the scatter graph, which compares pairs of values, so compares x and y values. Now choose the one that's joined up, the other one is quite difficult to read, and you can see there we have a graph, which is the kind of graph we'd expect for a cubic. Okay, kind of two little peaks on it there. Right. Now, that's our graph created. Now, it's always, as always, it's important to have a title. So we're just going to do that now, and we'll keep the legend in, even though we don't need it yet, but we will need it when we create our new sets of values. So we're going to have another set of values alongside our first set, and they're going to be the transformed values. Right. So just to add in a title there, chart title, above chart, and just basically put in the name of the function, y equals 5x cubed minus 8x plus 12. Now, to create our second lot of values, we go to the second part of the question, and we're asked to transform, to scale our x values by a half. Now what this means is that we multiply each x value by the value a half. So again, to label this accordingly, 0.5. Just divide by 2 also. And in the second case, we're asked to translate by 1 in the y direction. So it's y plus 1. Okay, so scaling is always multiplication, and translation is always adding or subtracting. Okay, so when we're scaling, we're making something bigger or smaller, in this case smaller, because it's by a half, and when we're translating, we're moving the set of values. Okay, so we're moving it to the left, the right, up or down. Okay, in this case, we're moving it up by 1 unit. Okay, so all we need to do here is put in a simple formula which basically multiplies each x value by 0.5. So we just choose the first x value and multiply it by 0.5. And we can just use autofill on the rest of them. So automatically it'll move down as we move down. And for this one, we're adding 1 to each y value. So just choose the y value. We don't have to put in the formula again. You just literally click on the value itself and add 1 to that. Again, we could do these in our head, but I would like you to do, in a test, I would expect you to use Excel to do it, and also it's quite easy to make mistakes if you're doing it manually. So now we have to add in those values into our other graph, into our original graph, and compare. So basically this is the same graph, except the only difference is we've transformed it in the x direction and in the y direction. In the x direction we've multiplied by half, each value by half, and the y we've added on 1 unit. So the shape remains the same, it's just that the graph is either going to be stretched or shrunk or moved in some way or another. Right, so to do this, to add in the set of values, we do as we always do to add in anything to our graph, and we right click, select data, and we add another series. Before that we just edit the series to name it, so we just give it the name original, for example. Okay, so that's the original graph, just so that someone looking at it will know the difference between the two, will know which is which. And then we add another one, call it transformed, or you could specify, x multiplied by a half, y plus 1. Notice in this scatter graph, it asks us for x values and y values, so it plots those for every x value it plots a y value. So we go to series x values, we select the x values, and we go to the y values, and we select the y values. And now this graph has been added into the original, and we're done. So we have the original graph and we have our transformed graph.